In this session, we're going to talk about logarithms. Now, this is an introductory part to logarithms. Now, a logarithm is just a function that is defined as, if we say f of x is equals to log of x, then let's say the base is a. Okay, so a logarithm will just be an inverse of the exponential function. So as we introduce this topic, you have to know how to convert from logs to exponentials, which we are going to talk about later on. But now, what do we have here? The x is called the input of the log. Then the a, in this case, this one is called the base of the log. So these are what we are going to be talking about. Now, it's very important to talk about also the types of logarithmic functions. Okay, so I'll mention two. The first one that you have to know is what we call a natural logarithm, and the second one is called common logarithm. Now, this is very important for you to know. So a natural logarithm is just given as log of, let's say, x, then the base is e. Okay, it to mean that this is a natural log, so we just express it as in x. Okay, then on the other hand, a common logarithm is just a log, let's say log of x, then raised to the base 10. So this will be the common log. Now, the natural log, the e that you're able to see, this one is what we call, this is a mathematical constant. Okay, what we call the Euler's number, and it's equivalent to 2.71828. So able to see that this is an irrational number. It can't be expressed as a fraction or a decimal finite number. Okay, so this is very important for you to know. Now let's talk about something very vital, the properties of logarithmic functions. Okay, so properties. Others might call them identities. Okay, whichever resonate with you. Identities of logs, or let's just say the basics, equation that you need to know. Very, very important. So the first one that you need to know is that if you are given the log, let's say log of a, and the base is a, this is equivalent to a 1. Okay, this is very important for you to know. Then rule number 2 that you are supposed to know is that if you are given the log, let's say of the log of 1, the log of 1 is always 0. This is very important also for you to know. Then rule number 3 is that if you are given a log, let's say log of x, the base, let's say it's a, then this x has a power. So the power is going to drop. You are going to have b. You write your log of x and your a. This is very important for you to know. Then another scenario that you need to know, as a property, is that log in base e, let's say log of x in base e, this is equivalent to the natural log. Okay, I n x. Then another rule that you are supposed to know is that the law of addition of logs. Okay, let's say you have a log of let's say a, you are adding it plus the log of, let's say, b. These have the same base. Let me say the base is x. So what you are going to do is that this will be equivalent to, or to be equals to, the log, you get your base, which is x. The two logs, since they were adding up, you are going to multiply them. Okay, so a will multiply by b. Always start with the one that comes first. Okay, always start with the one that comes first. So that is very important for you to know. Then another rule that you are supposed to know is allow me to write it here. Rule number 6 is about if you've got a log of, let's say the base is x, the log of a minus the log of b, they have the same base of x. So what you are going to have in this scenario is log of x. Then what you're going to do now, since they were subtracting, you're going to divide them. Okay, so a over b, always start with the one that comes first. So this is very important for you to know. Then another scenario that you're supposed to know here is let's say the base, you have the base, then you have a log on top. Okay, log, and this log has a base of x. So this scenario always give you x because this is supposed to give you 1. Okay, so these are the basic properties that you need to understand on logs. Okay, let's just solve a few of simple questions just to cement it further. Okay, so let's start with the first one. The first one, we said, if you have a log of, we're not going to talk about the one for log of, log of 1 will always give you a 0. So this is very important for you to know. But now if we say log of a and log of a, we said is equivalent to 1. A good example here is if you've got a log, let's say of 2, this has a base of 2. So this will always give you a 1. That's what we're talking about. The other scenario is if you've got a log, let's say of 10 or 10, this will give you still 1. Okay, so this is very important for you to know. Then if you've got let's say the natural log, then you've got e. This is the same as log. E is the base and is e like that. So this will give you still 1. So this is about the first principle. So that's very important for you to know. Okay, then the second rule that we can talk about is the one that we said if you've got a log, then let's say then you've got b here. Okay, what you're going to do is that your b is going to drop. Okay, so that is what we said. So you have a b, a log of, let's say, x and a. Okay, so this will be the scenario. An example that we can give on this one is if, let's say, you have a log, let's say log 8 raised to base 2. So what I'm going to do, that you can write log 8 is just the same as 2 to the power 3, right? Okay, then the base is 2. Then what is going to happen is that the 3 is going to drop and come in front of the log. Okay, so what are we now going to have? We are going to have 3, the log of 2, base 2, like that. Now we're not yet done, because you know that log of 2, this log of 2 and the base is also 2. So because they are the same, so we're going to have 3, and we said that that expression is going to give you 1. Okay, from our first property. Then you're just going to remain with 3. So this is how you're going to solve this one. So this is very important for you to know. See you in the next session, where we're going to be talking about other application of these rules.